Continuing this example further, so instead of finding the GCD of 91 and 287, we find the GCD of 91 and 14. Okay, and we simplify this further by repeating the same process, and we try to find the remainder by using the divisibility algorithm again. Okay, so express 91 as 14 times the quotient plus the remainder. So we find out that the new remainder is 7. And again we realize that if we take this term to the left hand side, 7 will have the same GCD as the GCD of 14 and 91. Okay, so instead of finding the GCD of these numbers, we can reduce the problem to finding the GCD of 14 and 7. And now we realize that 14 is a multiple of 2, which means that the remainder of this process is 0. And this implies that the GCD of 7 and 14 is going to be 7, because 14 is a multiple of 7, so 7 is the common factor, and that is the greatest common factor or divisor for 7 and 14. So in other words, we have solved the original problem by breaking it into smaller parts and by realizing that the GCD of 287 and 91 is same as the GCD of 91 and the remainder of these two, which turned out to be 14, and GCD of 14 and 91 is going to be the GCD of 14 and the remainder of these two numbers, which is 7, and this GCD can easily be computed because the remainder is 0 to be the smaller number 7. So the GCD of this original problem is actually 7.